everyone, my name is Carina, and today, yes, I will talk about how to become a real programmer from nerd to Googler. And before I will begin, I would like to ask you, who is familiar with Java and C++? Okay, who is familiar with Java and C++? Not like, okay, I haven't even heard about that. Who is familiar with it like full-time coding? Okay, not a lot. And with the JavaScript? Full-time coding. Also, I was expected, so I can continue with my presentation. And one more question, and it will be a bit spoiler. Who is familiar with hash tables? Okay, could I please ask you, just forget about this data structure for the next few slides. Okay? Thank you, guys. So now let's begin. I'm going to demonstrate you a task. I took this task from a book like Cracking the Coding Interview. This book is suggested by Google to prepare for them interview. And this presentation I prepared in a collaboration with a Google engineer. So it's not a real task, but it's sort of a task what you can be asked in a Google interview. And it's time for the task. Given two strings, write a method to decide if one is a permutation of another. Okay, at first let's decide what is the permutation. I think it's the first what we should begin. And the permutation is a way, especially one of several possible variations in which a set of number of things can be ordered or arranged. To make it more clear, let's take a look to an example. So, what we are going to do? We will write a function, and this function receives the string, the second string, as an argument, compares it with it, and returns true or false if this guy is a permutation of this one. Yeah? Any ideas how can we do that? No ideas? Yes?
Sort the sort charges and what strings and compare.
Exactly. Let's take a look. Here's our function, and this function receives two strings, as we discussed. But at first, what we want to do is compare the lengths of the strings, because if the lengths are different, it's not a permutation, it's obvious. And after that, we return, we split the string to an array, we sort it, and join it back. And after that, we do the same with the string, as you have just said, we compare it. But the next question, how can we decide, is it function good enough for us? How fast is it? I don't know. We just, okay, yeah, it works. Yeah, exactly, it will do our work. But if we are talking about Google or big companies, they care about how fast is your code, because it's money, and they want a lot of money, and they achieve it. In this case, big O notation helps us. But the next question, what is the big O notation? And let's ask Wikipedia. Wikipedia knows everything. And Wikipedia tells us that big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value of or infinity. What? No, it's really nice, but yeah, what is that? Let's imagine the next scenario. We have a file on a hard drive, and we want to transfer this file to our friend. And our friend, for instance, in where? Somewhere in another side of a country. How can we do that? How can we transfer a file to our friend? Any ideas? We can send them by email. Yeah? Okay. How also can we do that? Yeah?
Using torrents.
As an option also. Any other ideas?
Carrier pigeons.
Hmm?
Carrier pigeons. Carrier pigeons.
Yeah? Also as an option, but I think it will be a bit slow. Other options?
Upload to cloud and share the link.
Also. Okay, but in a case, if we have a really huge file, like 1 or more terabytes, it can takes days.
Buy train ticket and improve the hardware.
Also, yes, exactly, we can do that and it will be faster for huge files, right? So we can do it with, for instance, as we say, with an email, torrents, pigeons. We can do it by train, we can do it by airplane. And actually, it describes our algorithm runtime. And here, there is a schema. And if we are talking about an electronic transfer, I will explain it. That means that it will be this guy. So, as our file, as it's bigger, it will be lower in the time. In case if we are talking about pigeons, in case if we are talking about trains, or we are talking about airplanes, cars, or etc., it does not matter how big our file is. Every time it will be the same, it will be constant. As you can see, there are a lot of different runtimes. How can we describe it? Also, it can be a combination of runtime. Also, as another example, for instance, you want to paint a fence with the width as W and with the height as H. And in that case, the runtime will be W multiply H. If you want to do it with a few layers, like a L, it will be WHL. So nothing special. But let's go back to our function, what we have just done. What is the big O of this function? Here we used a sort algorithm. The sort algorithm in JavaScript is an implementation of really famous, I would say, quicksort. I hope some of you has even heard about it. And the runtime of the quicksort every time is n multiplied to logarithm n. Here we use it twice. And at the end, the complexity of our function is 2 multiplied to 30 guys. Every time you can reduce your constant, so at the end, the complexity is n multiply logarithm n. But how can we do it faster? Like this, like linear. And now it's time to remember about hash tables. Let's take a look. Who is it? At first, hash table is a data structure. And what is it? This data structure takes an object and using a hash function, it converts it into a hash code. And after that, it takes its modulo, table size, and return a table index. And at the end, it does it like this. It reverts it into key value pairs. And every time, inserting and getting something from hash tables, the complexity equals 1. So the fastest in our case. Can we just feel it? Guys, do you feel it like you become a real developer after that? And when we use our hash functions, we also expect that the hash function will have a specific properties. And the first of them is a pre-image resistance. So, how it works? If we provide a value for this function and it returns, in our case, an output, it should be mathematically difficult to find an input. So, reverse it. The second property is the second pre-image resistance. It should be difficult to find also the same value. So if we have a hash, we have a hash function, we provide x, and it should be difficult to find, providing an y, this value. And the third one, it's a collision resistance. It should be difficult it should not give us the same results for two different inputs. Also for inputs with the different lengths. It's also really important for us. In our situation, for instance, if you want to use it as an index for our hash table, we could have two the same indexes, but for different values. And in that case, it won't work as we want. So, and now, let's revert our function with using hash tables. Here is again this permutation. We still need to check it first the length. And after that, we create our hash table. And you know what is the magic thing about hash tables in JavaScript? In the programming languages as Java or C++, there you can find the data structure as a hash tables. You can use it directly. The magic about the JavaScript that our objects are hash tables. V8 implements object as a hash tables. You shouldn't do something, like extra movements or something like that. Your object is a hash function. It's a trick. And now let's take a look. Here we create a function for that and we provide a string. And as I said, as I promised, we create just an empty object and we will return that. After that, we go through all symbols in our string and we convert our symbol into charted code. We take it code. And after that, we check it. If we already have this key in our hash table, in our object, we just increase it. I'll explain it a bit later. And otherwise, it equals 1. Actually, what are we doing here? We just count how many the same symbols has our string. And after that, we can check if it's permutation or not. And the next step, using object is, actually we just compare to object. It's a built-in method in JavaScript. We return it. And now, what is the big O in this case? As we have already discussed, create inserting into a hash table is a constant. And going through our string is a linear. Because here, n is actually an amount of symbols of our string. And in the end, it's n plus 1, what actually equals linear. Ta-da! But let's take a look for the next task. It's a bit difficult than this one, but it's awesome. Given a string, write a function to check if it's a permutation of a palindrome. Palindrome is a word or phrase that is the same forwards and backwards. A permutation is a rearrangement of letters. And again, an example. This guy is palindrome, and this one is rearrangement of this palindrome. And now we need to write a function if this guy is a permutation of that one. Okay, but the next task also for this one, how to do it linear. What? Okay, any ideas how can we do that?
Use the previous solution.
Yes, exactly, but using a hash table. You mean like this, right? Copy paste it. I like to copy paste it. Also, it's a part of real programmer to copy paste a lot. Also from Stack Overflow. But let's take a look for an example, and we can see something interesting. There are two palindromes, and look at the magic. If we will bit rearranged the letters, what will we see? It's a pair, and look here. The funny things about palindromes that if you rearrange letters in palindrome, every time it will have, every symbol will have an even amount, or it will have even amount plus 1, but only 1. And actually it's a trick. How can we do that? So, let's go back to our function. We create a hash table, we insert our string, and we convert it to hash table. And the next step, what we do, we go through every value in our hash table and we check it. If it's even, that's fine, we don't worry about it. But if it's odd, we increase our flag. And if it's more than 1, it's not a palindrome. Because palindrome can have only one symbol, but which does not have a pair. But what is a big O, as usual? Let's take a look. This guy, as we discussed with the hash table, is linear. And this one is also, because we go through every symbol again in our hash table. And here is a sum of them. And we can reduce 1, and we will receive linear. That's it. That's the magic. Any questions?
How to become ruler?
It's a good question. I'm also thinking about it every day, and how to become. I think at first you have to have a really strong background about different data structures. And the first thing to become not a Googler, I would say, how to become a real programmer. I would answer to this question, okay? Because for me it's almost equal. When you write your code, and after you did that, I think you have to ask a question to yourself. How is it fast enough? Is it good enough? How can I improve it? How can I do it faster? With less lines of code and with good complexity. Because of course you can write your code with a complexity, I don't know, like n square or something like that. I mean, when it's really, really slow and it will work. But every time you have to think, how can I improve my code? How can I do it better?
And to find an answer, I have to use Google, I guess.
Exactly, because Google knows everything. By the way, guys, do you know, I didn't know about that. Today is birthday of Google, and Google today 20 years old. Yeah. Yeah, so for me.
Applause for Google.
Huh?
Applause for Google.
Yes, exactly. And for me a bit. More questions? Any questions? More?
Another question.
Yeah.
Do you use hash tables at your work?
Yes, I do. I use it, hash tables like mappers because it's really useful. By the way, today I have used it, and yes, I can explain what I did. I had a bug on Safari, and Safari didn't play an audio accidentally. I don't know why. And that audio was recorded on Samsung device. And only from a few types of Samsung device on Safari, audio does not work. Audio was converted into a blob file. Question, how to solve it? Where is the problem? The problem was in the MIME types, because Safari used a specific MIME types and I had to manually change that. Yes, it's really weird, but it's Safari. It's like a second Internet Explorer. Not, of course, like Internet Explorer, but...
Fancy ones.
Yes, exactly. For Internet Explorer, luckily, we have a polyfills, but not for Safari. And also, I wanted to do generic to replace this MIME type every time. And I create a sort of a hash table. And if a hash table has a key with a not working MIME type, replace it with a value. If it does not, just leave it. So, and that means that I easily can update my hash table and if something will go wrong. Otherwise, it will work for other data files. So guys, use it. It's really useful and it's faster, as you saw.